everyone. Last session we discussed about some fundamental elements of networks, and also we discussed about some fundamental concepts of different electrical elements, as well as what is the difference between network and circuit. And also we discussed about some different types of sources. So in that we discussed about ideal source, practical source and dependent source. The syllabus starts with practical sources. In last session I explained what is practical sources. If it may be a voltage source or current source, the source with internal resistance, hence there is a internal power loss. Such type of sources are known as practical sources. Now in this session I am going to discuss about how to obtain equivalent current source for given voltage source, vice versa. Okay. Then after this concept I would like to solve some problems based on this source transformation. First let us consider one practical voltage source, -2 plus, polarity is given. Next 100 volts. So if it is practical source, yes, it should contain internal resistance. So let me write internal resistance of value 10 ohm. Okay. So now we can call this as a practical voltage source. So what is practical voltage source? A voltage source with internal resistance. How the internal resistance is connected to voltage source? The internal resistance is connected in series. Okay. The voltage source value 100 volts and internal resistance value 10 ohm. Now by Ohm's law, what is the formula? V is equal to I into R. So in this circuit V is given how much? 100 volts. V is given 100 volts and R is given. R is equal to 10 ohm. Okay. So out of 3 variables, 2 variables are known, V and R. Yes, we can find out what is I. I is equal to V divided by R. So V is equal to 100 volts, R is equal to 10 ohm, I is equal to 10 ampere. So by replacing this practical voltage source by a current source, that current source value is 10 ampere. You know that in practical current source, the resistance is connected in parallel with the current source. Okay. So first let me write the current source. This is a current source. How the internal resistance is connected to a current source? That is always parallel. Okay. So these are the terminals of the source. So what is the current source value? 10 ampere. Then what is the internal resistance value? The internal resistance value is same as internal resistance of voltage source. Once again, that is also 10 ohm. Now the question is, say in a given practical voltage source, the polarity is from minus to plus. So current always drives from minus to plus because the electrons concentration always high at plus, I mean higher potential end. The electrons always diffuses from higher potential to lower potential. Conventionally, the current always opposite to flow of electron direction. That's why the current direction is always from minus to plus with respect to source. This is the current direction. That's why for this given polarity, current source direction upwards. And what is the value? 10 ampere, and resistance value same as practical voltage source internal resistance value. If you want to verify, yes, once again convert or obtain a equivalent current voltage source for this current source. Again by Ohm's law, V is equal to I into R. So V is equal to I is known how much? 10 and R is also known 10. So V is equal to 100 volts. See, this is same as 100 volts. So this is known as source transformation. What is source transformation? Yes, we can convert practical voltage source into practical current source, equivalent current source, and also yes, once again we can convert back the given practical current source into voltage source. That is done by using the simple law, Ohm's law, by using the formula V is equal to I into R. So this concept is known as source transformation. This concept we are using during the simplification of complex circuit. Say if any circuit is given with n number of sources and n number of resistance, we can replace this complex circuit by a simple circuit by using so many techniques. One is the source transformation technique, other one is star to delta transformation technique, and sometimes we can use some important network theorems also. So out of these concepts, this is the one of the concept. What is that? Source transformation technique, in order to replace a complex circuit by simple circuit. Now I would like to solve one simple problem based on this concept by using source transformation technique. Okay. Yes. Now first I would like to solve one simple problem based on this concept. What is that concept? Source transformation technique. See, the question is, find the simple circuit or obtain a simple circuit between the terminal A and B for a circuit shown in figure. See, first let me explain what are the components the circuit consists is 5 volt voltage source, again one practical current source. This is ideal voltage source because this exists without any internal resistance. This is a practical current source. Once again one more practical voltage source and current source, again practical voltage source. So that is what we are going to obtain, equivalent circuit between the terminal A and B. See, we should not touch these two terminals till end of the problem, because these two terminals are the reference. These two are the terminals where we are going to find out a equivalent circuit, I mean effective circuit between these two terminals only. Okay, before converting any practical voltage source into current source or current source into voltage source, we should think what is the next step, whether we are going to get any current source in parallel or voltage source in series. After that only, yes, we have to decide whether we can convert these practical sources into another form. Okay, first let me consider this practical current source. Yes, we discussed how to replace practical current source into practical voltage source. So, see, in this practical current source, I is given how much? 2 ampere, and R is also given 5 ohm. Yes, we can find out V by knowing I and R. What is the formula? V is equal to I into R. So, 5 into 2, 10 volts. 5 into 2, 10 volts. So, next let me write this circuit, say -2 plus, that resistance, the practical current source resistance, what is that known as? Internal resistance comes in series with this practical voltage source. What is that? -2 plus 10 volts. See, according to this current source, what is the direction of the current source? Reverse direction. Okay, so according to this direction, what is the polarity of voltage source? Current always flows from minus to plus. Then what is the resistance? 5 ohm. Then what is the voltage source value? 5 volts. I hope all of this point is clear. I just converted this practical current source into voltage source. So that's why I am getting a chance of getting two voltage sources are connected in series. When two voltage sources are connected in series, yes, we can replace these two voltage sources by a single voltage source. So, two sources can be replaced by a single source. Similarly, yes, in this path, we can see a practical voltage source here. Practical voltage source, 2 volt voltage source connected in series with a 1 ohm resistor. So, here also, yes, we can replace this practical voltage source into current source. So, what is the next step? In the next step, we are going to get 6 ampere current source in parallel with this current source. So, when two current sources are connected in parallel, yes, we can replace it by a single current source. When these two current sources are flowing in same direction, addition. When these two current sources are moving in opposite direction, subtraction. Now, let me replace this practical voltage source by a current source. V is given, R is given. What is I? I is equal to V by R. V is 2 volts divided by R, 1 ohm. What is 2 by 1? 2 ampere. So, let me draw here itself. Yes. So, the current source. See the polarity plus to minus. Then what is the current source direction? Reverse direction. What is the value? 2 divided by 1, 2 ampere. Next, that series connected resistance comes in parallel. Comes at parallel. What is that resistance value? 1 ohm. Okay. Again, let us draw 6 ampere current source in the same place. What is the direction? Forward direction. Next, at last, one more branch is remaining. What is that? 9 volt voltage source connected in series with 3 ohm resistor. Yes, we can replace this practical voltage source by current source. V is given how much? 9 volts. R is also given 3. Then what is I? I is equal to V by R. V by R means 9 divided by 3. What is 9 divided by 3? 3 amps. What is the direction? So, polarity of voltage source is minus to plus. The direction of the current source, see, the direction of the current source is forward direction. What is the value of the current source? So, V by R. So, 9 by 3, 3 amps. Okay. Next, just complete this path and also write the series connected resistance comes in parallel. Okay. Say the next step is, see, two current sources are connected in parallel. We can replace these two current sources by single current source, and at the same time this current source is also connected in parallel. Before that, at a time we can replace all the current sources by single current source. That's why first we need to replace this. Two voltage sources are connected in series by a single voltage source. See, this is minus 2 plus 5 volts plus 2 minus 10 volts. Two voltage sources are connected in series with a opposite polarity. That's why subtraction. So, higher value minus lower value. So, 10 volts minus 5 volts, 5 volts. 10 volts minus 5 volts, 5 volts. The polarity is always higher voltage source polarity. Higher voltage source polarity. See, now two voltage sources are replaced by single voltage source 5 volts. Now, once again we can convert back this practical voltage source into current source. So, V is known how much? 5 volts. Again, R is 5 ohm resistor. Then what is I? I is equal to V divided by R. What is V? 5 divided by R. Again 5. 5 divided by 5. 1 ampere current. What is the direction of 1 ampere current source? So, the direction of the voltage source is from plus to minus. Then what is the direction of current? Reverse direction. Let me write that current source reverse direction. How much? 1 ampere. That 5 ohm resistance comes in parallel. So, don't forget to write that between the terminals A and B. Okay. Just I would like to rearrange the circuit. without changing any configuration of the circuit. Just see. Just connected to a common point. So there is no change in the circuit configuration, just I rearranged the circuit connection. Is that clear? Now you can say there are 4 current source are connected in parallel. 1 ampere current source, 2 ampere current source, 6 ampere current source and 3 ampere current source. Out of these 4 current source, 2 are connected in reverse direction, direction of the current source, 2 current source direction, forward direction. First, next, these 2 current sources are replaced by a single current source because these 2 are flowing in same direction, 1 ampere plus 2 ampere, 3 ampere. So, let me draw this. 3 ampere. Then what is the resistance? 5 and 1 ohm are connected in parallel. This is 5 ohm resistor and this one is 1 ohm resistance. Again, these 2 current sources are connected in parallel, again with the same direction. That's why we can add these 2 current sources, 6 and 3. So 6 plus 3, 9 ampere. So what is the direction of the current source? 9 ampere. Then what is the resistance? 3 ohm resistance. Again, the terminals A and B. Okay, see the circuit is reduced. How it is reduced from the circuit 1 to circuit 2? Here we converted many practical voltage sources are into current source and current sources into voltage source. Why we converted? In order to get any current sources are connected in parallel way. Our voltage sources are connected in series because we can add when 2 or more than 2 voltage sources are connected in series. Similarly, more than 2 current sources are connected in parallel. Yes, we can add or subtract. However, we can replace it by a single current source or single voltage source. Now you can see 2 current sources are connected in parallel but with opposite polarity. So what is that? 3 ampere reverse direction and 9 ampere forward direction. So how we can replace these 2 current sources by a single current source? So subtraction. Higher value minus lower value. Then what is the resultant current source direction? That is always higher value direction. So first, so 9 ampere minus 3 ampere, 6 ampere. 6 ampere. So then what are the remaining elements? 5 ohm resistor. Next, 1 ohm resistor. Then one more, last one, 3 ohm resistor. So between the terminal A and B. Okay, now we can see only one source in the circuit, but there are 3 resistances are connected in parallel. How we can replace 3 resistance are connected in parallel by a single resistance value, I mean equivalent resistance value? Yes, you can use this formula 1 by RT. RT means total resistance or effective resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3. You know what is R1, R2, R3, 5 ohm, 1 ohm and 3 ohm. By finding the effective resistance of these 3 resistances are connected in parallel. So the value is 0.65. You can calculate and verify. So the current source value 6 ampere and the equivalent resistance value 0.65 ohm. So this is the terminal B and this is the terminal A. Okay. Still we can reduce this circuit into its simplest form. Again convert back this practical current source, sorry, this is not a resistance, this is current source with a direction, forward direction. Still we can find out its simplest form of the circuit by converting this practical current source into voltage source. I is given 6 ampere, R is also known 0.65. Yes, we can replace it by a single voltage source in series with a single resistance. Anyhow, the resistance value is same 0.65. How to find out voltage source value? That is V is equal to I into R. 6 into 0.65, that is 3.9 volts. Let me write at this point 3.9 volts. Polarity -2 plus 3.9 volts. Same resistance comes in series 0.65 ohm. So this is the terminal B and this is the terminal A. So this is the simplest form of circuit. I hope all of you understood this problem. So what is the problem? Find equivalent circuit, simplest equivalent circuit between the terminal A and B for the circuit shown in figure. In the circuit you can see the many combination of practical current source and voltage source. Should have idea after converting any practical current source into voltage source, what is the next step? So if you are converting into current source, there may be a chance of getting 2 or more than 2 current sources are connected in parallel. If you are converting practical current source into voltage source, there is a chance of getting more than 2 voltage sources are connected in series. Then only we can replace the multiple number of sources by a single sources. It may be a current source or voltage source. This is the way we can simplify the given circuit by using source transformation technique. Okay. Yes. Now let us discuss the second problem. Once again the problem is find equivalent circuit or simplify the given circuit by using source transformation technique. See in this circuit, first let me explain the circuit, how it is connected, its configuration. One practical voltage source, 10 volt voltage source in series with 2 ohm, that is connected in parallel with 3 ampere current source. Again one more resistance is connected in parallel. So in this combination 12 volt practical voltage source with an internal resistance 3 ohm. Again 2 ampere current source is connected in parallel. The entire combination is connected parallel of the practical voltage source 5 volts with an internal resistance 2 ohm. Here the question is find a simple equivalent circuit between the terminal A and B, between the terminal A and B. So first step is what we can do in this problem. First see how many practical sources are there. One practical voltage source. So one more practical voltage source. So here one more practical voltage source. First replace all the practical voltage sources by practical current source. First let me draw. Anyhow V is given and R is also given. So by Ohm's law I is equal to V divided by R. So 10 by 2 5 amps. Then what is the direction of that current source? According to this voltage source polarity, it supplies the current from minus to plus. That's why the current source direction upwards. Okay, what is that value? 10 divided by 2, 5 ampere. Then this practical, internal resistance comes in parallel because internal resistance always connected in parallel with current source. What is that internal resistance value? 2 ohm. Again, let me write 3 ampere current source in parallel. Then one more 2 ohm resistor. After that, convert this practical voltage source into current source. So I is equal to V divided by R. Again V is given 12 volts. R is also given 3 ohm. So 12 by 3, 4 ampere. So what is the direction of the current source? Upwards. What is the value of the current source? 4 ampere. That internal resistance comes in parallel. What is the internal resistance value? 3 ohm. So just complete this circuit. So after that 2 ohm resistor is connected in parallel with this combination. How much? 2 amps. Again that last. So before converting this practical voltage source into current source, let me complete the first part of the circuit. So this resistance with a voltage source value minus to plus 5 volts. Okay. Next, I think it's better to simplify in this circuit only. 5 ampere and 3 ampere are connected in parallel with same direction. Both are flowing, both are supplying the current upwards. We can replace these two current sources by a single current source. What is that resultant current source value? 5 plus 3, 8 ampere. So similarly, two resistances are connected in parallel. Yes, we can obtain a effective resistance when two resistances are connected in parallel. 2 into 2. 4 divided by 2 plus 2, 4. So the effective resistance value becomes how much? 1 ohm. Okay. Next, say two current sources are connected in parallel but opposite direction, because 4 ampere current source supplies the current in upward direction, 2 ampere current source supplies the current downward direction. When two current sources are connected in parallel with opposite direction, yes, still we can replace it by a single current source, but the value is higher value. How to find out the effective value? Higher value minus lower value. The resultant source direction always same as higher value of source direction. So 4 minus 2, 2 ampere, the resultant source direction is higher value source direction only. Now let me delete this. Okay. So in the next step, the circuit looks like this. Is that clear? So next, again we can replace these two practical current source into voltage source. So there is a chance of getting two voltage sources are connected in series. That's why I am replacing these two current sources, practical current sources, into voltage source. So I is known and R is also known. V is equal to I into R. So 8 into 1, 8 volts. So first let me write. So polarity, current direction, current source direction upwards. That's why the polarity of voltage source is minus to plus 8 volts. Then this parallelly connected internal resistance comes in series. That is 1 ohm resistance. Similarly, yes, we can replace this practical current source into voltage source. Again, the polarity is minus to plus. What is the voltage source value? V is equal to I into R. So 2 into 3, 6. So minus to plus 6 volts. This parallelly connected resistance comes in series. That is 3 ohm resistor. Is that clear? Now you can say in this branch, don't forget to write these two terminals till end of the problem, because this is the reference where we are going to find effective resistance between the two terminals, that is A and B. Now in the first branch you can see two voltage sources are connected in series with same polarity, minus to plus, and two resistances also connected in series. So when two resistances are connected in replace, is just an addition of two resistance to find out the equivalent resistance. Then what is the equivalent voltage source? 6 and 8. When these two are connected in series with the same polarity, that is 8 plus 6, 14 volts. 8 plus 6, 14 volts. Polarity minus to plus 14 volts. Next, two resistances are connected in series. One is the 3 ohm resistor, other one is the 1 ohm resistance. So the equivalent resistance is 4 ohm. Is that clear? Now how we can simplify the given circuit again by converting this practical voltage source into current source, and this one also, this practical voltage source into current source. Yes, voltage is given, known, and R is also known. How we can find out a current source value? I is equal to V by R. V is equal to 14 divided by 4. So what is the current source direction? Upwards. Current source direction upwards. Then this 4 ohm resistance connected in series comes in parallel. So 4 ohm resistance. Now tell me, what is the current source direction? Current source direction is upwards, fine. So 14 by 4 is 2.5 ampere. 2.5 ampere. Similarly, just replace this practical voltage source into current source according to this source polarity, current flowing downwards. Okay. So that's why, so this current source direction is downwards. So what is the current source value? So I is equal to V by R. V is equal to 5 divided by 2. 5 divided by 2 is 2.5 ampere. This internal resistance, series connected internal resistance, comes in parallel. Okay. Finally, two current sources are connected in parallel and two resistances is also connected in parallel, but with opposite polarity. Okay. Sorry, this is not a 2.5 ampere, this is 3.5 ampere. Okay. Next, two current sources are connected in parallel with opposite polarity. Yes, we can replace it by a single current source. So the single current source, I mean equivalent current source direction is upwards. Then value is 3.5 minus 2.5, that is 1 ampere. Next, when two resistances are connected in parallel, yes, we can replace it by a single resistance value between the terminal A and B. That single resistance value is 1.33 ohm. Still we can reduce the circuit into its simplest form again by convert back this practical current source into voltage source. First let me draw a terminal here A. Next first let me draw a internal resistance 1.33 ohm. So by knowing current and resistance, yes, we can find out voltage. V is equal to I into R. I is equal to 1, R is equal to 1.33. 1 into 1.33, 1.33 volts. So direction -2 plus 1.33 volts. So this is the given circuit, complex circuit. By applying the source transformation techniques, by converting practical voltage source into current source and practical current source into voltage source, we can replace it by its simplest form. Simplest form means what? Single voltage source in series with a single resistance. Thank you.